Hello and welcome to Math 1160 Survey of Calculus, formerly Applied Calculus, and in my mind, it's still Applied Calculus. If you're going to take one semester of calculus, what is it that you need? I've put a lot of time thinking about this, and it's not the traditional 1170, which is the other calculus course set of material. What you need is the ability to work with functions and to model and to be able to compute things in a reasonable way, and that's the focus. The focus here is applications, and so our real topic here is modeling with functions. You studied functions in Math 1143. Excuse me, my dog wants to say hi. Well, I guess I can't get her up. Anyway, there's a dog here, just in case you're wondering why I'm acting funny. And so you studied functions in Math 1143. What I want to do for today is, after we do a little bit of preliminary stuff, we want to, Sammy, you need to be patient. We need to do a little bit of review about functions and the like. First thing to make note of is that all of the course material is on Moodle. I have been working for the past little over a year on a calculus book. Portions of that will be available on Moodle, and the homework will be done with WebAssign, and that means that you need this number, ISU 40412745. That's our WebAssign course. You have to get WebAssign. That includes an electronic copy of the Hughes Hallett textbook that all of the sections use, and so this is an absolute requirement. Okay, so we're going to be modeling with functions, and one of the things that has not been emphasized is that there are two types of functions. There are active functions and passive functions. And what's the difference? An active function is something that you can put any value in except something that will make it blow up, and that you can do things. That usually means having a formula. So if I write down a function like this, that is an active function because I can put in any x. Now, some x's will make this not work because of the square root, but if I put in x is a half, or x is 1 over pi, or x is 1 over 2e, or whatever, I can in principle calculate the value of this function, and so that makes it active. You can do stuff with it. Active functions are what models are constructed out of. The opposite is a passive function, and that's usually given by a table of values, and you're stuck with it. You can't go and get new values. You can't make up anything, and so you're just stuck with what you've got. So I'm writing down an example of a passive function. There we go. Table of values. If x is 2, then you can read off that f of x is 0. If x is 2.5, nope, can't do it. If x is 3, f of x is 9. If x is 2.5, nope, can't do it. So that's pretty passive. You can't change it in any way. And so a model takes data, which is a passive function, and creates from that an active function that is supposed to duplicate what's going on with the model. And based on that, you should be able to make predictions about the model. They may or may not work about reality, but that's what we're aiming to do. Okay. The way we make models with calculus is by tracking the changes. That's what makes calculus different from other things you've done before, and so that's what we'll be focused on over the course of the semester, and that's the big difference. So we're always looking at how things change. That is a good way to make models, and it's been very successful for a lot of other people. A couple of things about what this model making process is some idiot decided a few years ago that we should not have any trigonometry in Math 1160. Unfortunately, that idiot was me. And there were good reasons for doing that, but over the years I've come to decide that that is not the case. We do not have a trig prerequisite, so we're going to cover a few basics about trig and use those basics. We're not going to go off into the esoteric stuff that happens in Math 1144. We're just going to use some basic things because you can't make good models of the world without trig, and so we're going to fix that. You're welcome to complain that because there's a complaint thing on the syllabus, which is on Moodle, but we're going to do a little trig, and it's the right thing to do. Okay. So that's the introduction. I really like calculus, and I have found it to be very useful. A lot of people have found it to be very useful over the years, and so we're going to keep using it, but we're going to keep in mind that you are not here to be a math major or an engineering major. The kinds of things that you're going to do with calculus in your future courses will be very different from what they do, and that is very much in my mind that we're going to focus on some applications. Okay. Let me remind you about some things from the prerequisite Math 1143. And so first of all, we've got this function notation that you should have had pretty well drilled into you all the way through Math 143. And we're going to kind of break this down. So we have this famous expression, y equals f of x. Whew! And so what you've got out of this is that f is the name of the function. That's what we call it, f. Hey, look at that f over there, or look at that g. We can use other letters. Usually if we're using f for the function and x for the input and y for the output, that means we're being abstract. That means we're not being applied. And so we're trying to be very general. Okay, so there it is. F is the name of the function. X is the input. And you can put in any input as long as it doesn't blow up like taking square root of a negative number. So x is the input, and y, or f of x, is the value. So we've got the name of the function f, the input x, the value y, and that's pretty much the standard notation. Now, a lot of times, like up here, if you have an active function, you have a formula for the function. That means that you have taken what the function does. It's active. It does stuff. You've taken what the function does and done it to x. So in this case, you've squared x, subtracted that from 1, and taken the square root. Those are the actions. So if you put in a half, you square a half, subtract that from 1, and then take the square root. Or if you put in 0, you square 0, you subtract that from 1 and take the square root. So we have to make a distinction in our minds and in our work between the action and the formula. And so let me write down an example function for how I think we need to think about this. So here's a function that I actually like quite a bit. The formula is f of x is 4x over x squared plus 1. Now this is backwards. That's not the action. The action's been done. It's been done to x. And so when we want to work with this function and see what it does, we have to do the stuff. And so let me walk you through doing that. And this is a very important way to think about function notation. So let's see what's gone on here. So here's the formula again. F of x is, I'm not going to say it out loud, because if I say it out loud, I'll say it wrong, unless you learn to say it the way I say it. So let's start by saying this out loud. What all is this formula that we have here? And the most important thing about this formula is it's a fraction. So that's how we start describing this function. it's a fraction. You can come up with some big word for that, but it's a fraction. If you have a fraction, then you have to worry about what the top is and what the bottom is. Now, we usually read from top to bottom, so there's a tendency to focus on the top. Where's the danger point with fractions? It's on the bottom, where you might divide by 0. That's how I got this scar in 8th grade, by the way. So when we talk about a fraction, we're going to say the bottom is blah, blah, blah. We'll fill that in. And the top is. When I talk about functions and formulas, this is the way I talk about them. When I think about them, this is the way I think about them. And I found that people who think this way are much more clear about what's going on with a function. And a lot of the calculus manipulations that we do later will depend on, wait a second, that's a fraction. Oh, now I know what to do because it's a fraction. Okay, so it's a fraction. The bottom is 1 more than the square. Square of what? Whatever you give it. So in the formula, you've given it x. But whatever you give it, the bottom is 1 more than the square. Where'd the bottom go? There's the bottom. X squared plus 1 is the formula for it. But what you've done is taken the square and added 1. Boom, you've got something. The top of the fraction is 4 times the input. So that's how we think about this function here. It is a fraction. The bottom is 1 more than the square. The top is 4 times the input. And now we can understand what the action is in this active function. Okay, so this is long enough for one video. There's going to be some more. The next one will be about the basic graphs and the basic functions that we use and how we can use those to really simplify the algebra. We don't want to do a lot of algebra. We do have to do some, but we don't want to do a lot of algebra. So go to Moodle, look at the syllabus. There's some activities there that kind of get to know you activities, and well, I'm hoping we'll have fun. So